Welcome to Arup's online maths class. Today we are discussing differential equation. Now first of all, it is wise to discuss what is a differential equation. A differential equation is that which includes dy, dx, d2y dx square, etc. If any of these things remain in an equation, this is known as a differential equation. Now one may ask that from where these differential equations are coming. Actually it is coming from an ordinary equation. When we are differentiating an ordinary equation, then it becomes a differential equation. Let us take the very common example, a parabola. Equation of a parabola, as you are knowing, y square equals to 4x. If we are differentiating with respect to x, so what we will get? 2y dy dx equals to 4a. Cancelling, what we can say? Y dy dx equals to 2a. Now see, remember this thing, that in a differential equation there cannot be any arbitrary constant. You have to know the difference between a constant and an arbitrary constant. Here 4 is a constant. Its value always remains 4. It never becomes from your childhood to now when you are very 4 always remains 4. It never be greater than 5. It never be less than 3. It is always 4 only. But a is called an algebraic constant. In different sum, a can acquire 16, minus 13, root 3 by 2, anything. That's why a, b, c, d, these algebraic constants are known as arbitrary constant. So in a differential equation, we have to eliminate this arbitrary constant. For eliminating, what we can do? From here, we can find a equals to y square by 4x. We can substitute here. So y dy dx equals to 2 into y square by 4x. 2 and 4 we can cut. Y and square we can cut. So ultimately what we are getting, that 2x dy dx equals to y. This is called a differential equation. You have to remember one thing. How many times we can differentiate it? We can differentiate it further. Can it? So it depends on the number of arbitrary constants. In this equation, there is only one arbitrary constant. So we can differentiate only once. We cannot differentiate to a higher category. Now let us take another example. Let us change it lightly. So such that y square equals to 4a into x minus alpha. Now see the difference. There are two arbitrary constants. A is an arbitrary constant, alpha is an arbitrary constant. So what we are getting? Now if we are differentiating 2y dy dx equals to 4a, again we are getting the same thing. And y dy dx equals to 2a. But we have to eliminate this a. And also we are knowing, since there are two arbitrary constants, we can differentiate it once more. If we are differentiating it once more, what we are getting? We are getting c here, it's the product. So derivative of y is dy dx into dy dx. So we can write dy dx whole square plus y into derivative of dy dx is d2y dx square, and that is equals to 0. Getting it here? Since we can differentiate this twice, so finally we are getting y d2y dx square plus dy dx whole square equals to 0. We can differentiate it twice because there were two arbitrary constants. So once again I will remind you that how many times we can differentiate a differential equation is depends upon the number of arbitrary constants. If only one arbitrary constant is there, you can differentiate only once. If there are two arbitrary constants, we can differentiate it twice. And we are bound to differentiate it twice. You cannot differentiate this one once. And if only one arbitrary constant is there, you cannot differentiate it twice. So in this way, we are getting a differential equation. So the source of a differential equation is an ordinary algebraic equation or any other. It may be trigonometric equation also. And conversely, what we can say? So equation, we have to solve. Any equation we are solving. In solving algebraic quantities, we are finding x and y. In solving trigonometric equations, we can find theta, etc. Similarly, what is the solution of a differential equation? The solution of a differential equation equals to is an algebraic as an equation. It may be algebraic, may be trigonometric. Okay. So I thought you can able to understand what is a differential equation, what is the source of a differential equation, how to form a differential equation, and from all differential equations, how to eliminate the arbitrary constants. Okay, thank you for attending this class.